Welcome to Pomodoro Joe for Wednesday, August 23rd, 2023. Today we're looking at LeetCode problem 767, Reorganize string. This is a medium problem. Given a string, s, rearrange the characters of s so that any two adjacent characters are not the same. Return any possible rearrangement of s or return an empty string if not possible. All right, we have some examples. A, B. The only way to do that is to have an A and then a B and then an A. All right, and then we have three A's and a B. Well, there's no way to rearrange this, so you have to return an empty string. Okay, this is pretty straightforward. So we'll put 25 minutes on the Pomodoro timer and get started. So for this, I need to know what letters I've got available, and I need to know how many of each letter I've got. So if any letter has more than 50% of the string, I guess we can go a little bit more than 50%. 51%, I don't have an exact number, but it's 50% plus 1. So those have to be different letters. They can't have more than one letter representing 51 or 50% plus 1. All right, I'm going off track here. Here's the plan. I know I need to alternate letters. So first I'll just go through and catalog what letters I have. I'll get every letter and the count of that letter. So I'll just have a dictionary that maps the letter to the count. After I have my counts of my letters, I'll sort them by their count. So essentially I will grab the most represented letter first, and then I'll grab the next most represented letter, as long as it's not the same letter as the first represented letter, and put in the next letter and keep going, alternating letters until I use up all my letters. So first, let's just have some result. That's going to be an empty string. And we will return the result at the end. Now let's get our counts. So let's see, this will be a default dictionary of integer. All right, and I'll just put a note here. The key is going to be the letter, and the value is the count of that letter. All right, next we can go through every letter for character in S. Our counts for this character are increased by 1. So now they've got my counts, I can go through and construct a new string. So let's see, how would I do this? Well, let's have some result. We have our result, and we can just say, while our result, or while the length of our result is less than the length of our S. So as long as the result is not as long as our string, our input string, we need to keep adding characters to our result. And then how do we add a letter to our result? Well, let's maybe have a helper function for that. So let's say next letter equals get next letter, and then we'll add that letter to our result. So our result equals result plus the next letter. Cool. All right, now I don't have this function for next letter yet, but this should help us. So now we have this function that should give us the next letter, and we can add that next letter to our result. Awesome. So let's create this function here. All right, so get next letter. How do we choose which letter to get? Well, let's see. We kind of have to know what our previous letter was. That might make a difference. So this get next letter needs to know what the previous letter was, because we can't have two letters in a row. So let's actually pass that in. So we'll have some previous letter. So that means that we have to pass in our previous letter here. And the previous letter is just, well, let's see, previous letter. All right, so let's have our previous letter. So that's going to be our result at the end. That's the last letter in our result, if we have a result. So that's if the result is not an empty string. Otherwise, we have no previous letter. Okay, that's pretty straightforward. Cool. So now we'll just go through and check to see if we can find a letter that's not this previous letter. And if we still have enough count, then we can return that letter. So let's do this. Our current letter is none. We might not return a letter. Now we're just going to go through all of our letters in our counts. So for our character in our counts, Now, if this character is the previous letter, we can't use it, so we'll just have to continue. So we'll just say if C is equal to the previous letter, we'll continue. We can't use it. Otherwise, this character might be a good choice for our next letter. But let's just check to see if its count is greater than our current letter's count. So we need to keep track of our count. We're looking for the letter with the maximum count. So we have a lot of some letter. We'd like to put that in here so we don't end up with a whole bunch of the same letter at the end, and then we won't be able to space them out with other letters. So we kind of want to use up the most represented letters first, and then try to interspace them with other letters. So what letter is this? Well, we need a letter count or current count. Let's call that letter count. And we currently have no letter, and our letter count is 0. Maybe I'll call it current count. I like that better. All right. So we've already checked that this letter is not our previous letter. Now let's check to see if this count is better or higher than our current count. So if the count for this character is greater than our current count, then let's replace this. So let's see, our letter will be C, and our current count will equal this count. So it counts for C. Awesome. And if we make it to the end, then we can just return our letter. All right. I think that's pretty helpful. So we have this little helper function. We can pass in our current letter or our previous letter. It will pass back the next letter. And this return is in the wrong place. There we go. Cool. All right. Now out here, when we pass in our previous letter, we might get no letter back. Well, if that's the case, then we have to return an empty string. So let's check that here. So if we don't get a next letter, then we'll have to return the empty string. Otherwise, we can add this letter to our result, and we keep going, and then we return our result at the end. And I totally forgot. When we use a character, we actually have to decrement our count. So our current count becomes this count at C, but then the counts, actually that goes out here. Before we return the letter, our counts for this letter, we're going to use it, so we have to decrement it by 1. All right, let's give this a shot. Okay, seems to work. Let's submit this and see if we can pass all the tests. And we pass all the tests. We don't do great, however. We only beat 25% for runtime, but we beat 99% for memory, so we actually do really well with the memory. All right, we can jump back here and try to do a little bit of cleanup, but I don't have a ton of time today, so let's do some really quick things. So let's see, what can we do really quick? One thing we can do, we can say if C is not the previous letter, and then only do this if block if C isn't the previous letter. All right, we can try that. And we do actually worse. Oh man, it's going to be a tricky one. Let's see, we'll go back to what we had. Let's just do some minimizing here. We can also get rid of this current count if we wanted to. All right, clean that up just a little bit. So this is a strange one. So because I'm using a default dictionary, as soon as I check for some value in the dictionary, if that key didn't already exist, it's going to modify the dictionary to create that key, which means that here, this count, I'm checking for this letter, it might not exist, so it's going to create it, but we're iterating through our keys right now, so that's going to cause a problem. So I might have to do one thing. Either we can create a none key, or we can check to see if letter is none. So try this. All right, we'll submit that, see how we do. Not much better. Now we're at 33%. It's our best so far, but still only 33%. So let's jump in here and see what other people are doing. Oh, they're using the collections counter. That's probably a good idea. So collections is a library in Python. It has a counter that we can use. This would probably be faster than our count. Oh, and they're using a heap. That's also smart. So they're using a heap to get the max counts, and I'm going through and finding new maxes every time. So that's pretty smart. All right, well, I don't have a ton of time today, so I think I'm gonna call it here, but if you want, give it a shot. Use that heap idea, I really like it. So check that one out. All right, so that is it for me on LeetCode 767. Hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code.